All right, let's look at the homework 4.3, problem number 6. All right, so we have this a function here involving sine and cosine, and we want to find the interval of increasing and decreasing. All right, so let's do that. All right, so we need to find the derivative, f prime of x is equal to, all right, so you have a 5, so if you take the derivative of that, so it's put 2 in front, so it's going to be a 10 cosine of x and subtract 1 from the power, and then multiply by derivative of cosine, which is negative sine. Right, and then you have a minus 10, and then derivative of sine is cosine, so cosine of x. All right, so if you simplify that, let's see, what can we do? We can pull out the negative 10. So we have a negative 10, so we can pull that out. So minus 10. And also, there's a cosine too. You have a cosine here, and then second term has cosine. So we can pull out the cosine of x. And what's left is going to be simply sine of x from the first term. And everything is pulled out, so it's going to be a plus 1, 1 left over from the second term. Right? So that's the first derivative. So we set this guy equal to 0. Right? Then we can see that, let's see, we can make either cosine of x is equal to 0. So we can make this guy. We can let this guy equal to 0, or we can let this guy equal to 0. So that means that either sine of x is equal to negative 1. Right? So x is between 0 and 2 pi, and we can just do maybe a unit circle. So I'm going to just draw a unit circle to figure this out. All right, so here's a unit circle here, going around like this. All right, so this is 1 here, negative 1 here. Actually, that's positive 1 there. So I have to change that to positive 1, and a negative 1 here, and negative 1 here. All right. So we want the cosine to be 0. So cosine is the x-coordinate of the point on the circle, on the unit circle. So we want that to be 0. So we are looking at the x-coordinate 0, so it's a point here, and then also a point there. So the angle is going to be, so this pi over 2, or you can go all the way down here, so that's going to be 3 pi over 2. So cosine equal to 0 gives you x equals pi over 2, and then you have a 3 pi over 2. Alright, and then sine is equal to 0. Sine equals negative 1. That means that x is going to be equal to, right? Sine is the y-coordinate, so we want the negative 1. It's actually this point. So it's actually the same answer as 3 pi over 2. Right? So we have an interval, right? So we're going to have a number line here. Alright, so we're going to put tick marks on pi over 2 and a 3 pi over 2. So I'm going to put the pi over 2 here. And then we have a 3 pi over 2. And then we're going to look at the sign of f prime. So f prime. Alright. Alright, so let's see. F prime is right here. So let's see. So f prime sits right here, and we just need to know the sign of things. All right, so here one thing is here you have a sine of x plus 1 is no matter what you do, it's going to be always positive because you're adding 1 to it. The worst case scenario, sine of x is going to be 0. but here, or negative 1, sorry. So this is going to be always positive, so we don't have to worry about this one. All right, so we just have to worry about the sign of cosine, right? So when angle is less than 1/2, so angle is like pi over 3, less than pi over 2, so less than 90 degrees, and the cosine is going to be positive. So we have a positive sign here. Negative times positive times negative is negative, right? So maybe I should probably put something here. X is, we can try pi over 3 or something like that. All right, so anything between pi over 2 and 3 pi over 2, so we can try x equals pi, right? When x equals pi, cosine of pi is negative, so it's going to be negative times positive, so it's going to be positive here, right? So we have a positive sign there, right? So anything bigger than pi, 3 pi over 2, we can try, let's see, x is equal to, will be the big, let's see, we can do 5 pi over 3 or something like that. So angle is over here, and we know that the cosine is going to be positive in the fourth quadrant, so it's going to be cosine is positive, negative, and positive, so it's going to be negative. Right? So once you have the sign, it's so we know that the function is function here is decreasing and increasing here and decreasing there. Right? So we want to, let's see, it's increasing between pi over 2 and 3 pi over 2. So let's type it in. Right? So increasing between pi over 2 and 3 pi over 2, right? And decreasing is everywhere else, so it's going to be a negative infinity to pi over 2, so pi over 2. And then, actually, so put the bracket, and then union, set notation here, union. And then starting from 3 pi over 2, to positive infinity. All right, so we have that. All right, let's check the answer. All right, I came back. Actually, I messed it up. It's actually starting from 0, so it should have been 0. All right, and then here it ends at 2 pi, so we're gonna have a 2 pi there. So we're gonna have a bracket there. And then I'm going to have a bracket there and a bracket there. Sorry about that. Whoops, so actually this is not what I want. Right, I need to have a bracket there, and that's it. All right, let's check the answer again. All right, I came back and looks like we got the part A correctly. On the second try anyway. All right, so let's move on to part B. We want to find a local minimum value and a local maximum value. All right, so look at that. All right, so maybe I should restrict yourself to from 0 to, this is actually the 2 pi, right? All right, so local minimum, looking at the picture, we know that here, we're going to have a local minimum there. And then here at 3 pi over 2, we're going to have a local maximum there. So we need to find the f of pi over 2. All right, so it's going to be 5, and let's see, cosine of pi over 2 is actually 0. So 0 squared. All right, minus 10 times sine of pi over 2 is 1, so it's going to be 10 times 1, so it's going to be negative 10. Right, so that's going to be the minimum. And the maximum is going to be, let's see, f of 3 pi over 2. Right, so 5 cosine of 3 pi over 2 is actually 0 again. But negative 10, and then sine of 3 pi over 2 is negative 1. So it gives you positive 10. Right? So minimum value is negative 10, and then maximum value is positive 10, right? So minimum value is negative 10, and then we have a positive 10, right? So we have positive 10. All right, let's check the answer. All right, it came back and looks like we got the part B correctly. All right, let's move on to part C. All right, so part C, we want to find the inflection points. All right, so we need to take the second derivative. Let's do that. All right, so we need to find the second derivative. So f double prime of x is equal to, all right, so we have to take the derivative of this guy here. So negative 10 is just a number, so I'll just leave it. All right, then we have to worry about just taking a derivative of, so cosine of x is the first guy. Second guy is sine of x plus 1. So we're going to use the product rule. All right, so let's do that. All right, so derivative of cosine is negative sine of x times the second guy. So we have a sine of x plus 1 plus first guy is cosine of x times derivative of sine of x plus 1 is cosine of x. So this is going to be another cosine times cosine of x. All right, and then if you simplify that, it's going to be negative 10 is still there, right? So we have distribute, so negative sine times sine, so it's going to be negative sine squared of x, right? Then negative sine of x, and then you have a cosine squared plus cosine squared of x, right? Since I want to either go all cosine or all sine, actually I want to go all sine. So I'm going to replace cosine of squared by 1 minus sine squared of x. Right? So what we get is going to be, let's see, negative 10 is still out here. Right, so I'm going to collect, let's see, you have a negative sine squared. You have another one, so it's going to be a negative 2 sine squared of x, right? And then we have negative sine of x, right? Negative sine of x. And then we're going to have, let's see, plus 1. So we have to take care of that. So we're going to have plus 1. All right. So in this case, I want to distribute this negative sign to all three terms so that we don't have to see so many negative signs here. So this is going to be 10. And then this is going to be positive 2 sine squared of x plus sine of x minus 1, right? And then we want to, since we have to set it equal to 0, I'm going to factor it out. So luckily, we can factor it out into, right? So this is sine squared, so it's going to be 2 sine of x, and then you need the sine of x here. Right, then since we need to get the plus sign there, so it's going to be plus 1 here and a minus 1 there. So if you multiply this out, you're going to get exactly that. So we can set this guy equal to 0. Right, so we have, right, either set this guy equal to 0, so we know that the sine of x must be 1/2, and or sine of x is equal to negative 1. All right, so we have that. All right, then we just need to solve this. Again, we're going to do the unit circle. So I'm going to draw a unit circle there. All right, and here's the x-axis, and here's the y-axis. All right, and then we need to find the x value. So sine is, let's see, sine is the y-coordinate of the point on the unit circle. So we want the sine to be 1/2. So 1/2 is probably around here. So 1/2. So we are looking at a point here, and also here. So if we're looking for the angle, so this angle right here is going to be a pi over 6, 30 degrees. And then if you're looking at the angle going all the way there, so it's going to be a 5 pi over 6. All right. So so we have that, and so we're going to just say x is going to be pi over 6 and 5 pi over 6. All right, then when sine is equal to -1, then we know that x is equal to, so sine's -1 is down here. So we know that the angle is, you go all the way down here, so it's going to be a 3 pi over 2. So x is 3 pi over 2. All right. Then we can just do a number line to see if there's a concavity change there. So we're going to just do this. All right, so here's x. So we're going to put, let's see, smallest one is pi over 6. Or actually, I have to restrict ourselves to 0. To largest is going to be 2 pi, right? And then we have 3 places. So I'm going to just put 1, 2, 3. All right, so for smallest one is pi over 6. Largest one is 5 pi over 6. And the other one is 3 pi over 2. All right, so we just have to determine the sign. Let's see, so here is the derivative there. All right, so 10 is going to be always positive, so we don't have to worry about that. And the sine of x plus 1 is going to be always positive. The worst case scenario is going to be 0. All right, but here, so we just have to look at that. So if x is between 0 and pi over 6, right? So sine is going to be less than 1/2. So it's going to be less than 1/2. So it's going to be negative. So we're going to have a negative sign there. All right. And here, if x is between pi over 6 and 5 pi over 6, so between these two guys, sine value is going to be bigger than 1/2, so it's going to be positive there. So it's going to be positive. Right, between 5 pi over 6 and 3 pi over 2, you can see that the sign here is going to be, so because sine of x is less than 1/2, it's going to be negative there. So we have a negative sign there. Right, and angle is beyond 3 pi over 2 and less than 2 pi, so angle is kind of down here. Sine is still going to be less than 1/2, so it's going to be negative. So sine actually doesn't change there. Right, so we have an inflection point there, 2 of them, right here, concavity changes, and here you have an inflection point there and an inflection point there. All right, so pi over 6 and 5 pi over 6. I'm going to just type it in. All right, so pi over 6, and then we have a 5 pi over 6. All right, so all you have to do is find the corresponding y value. So let's do that. All right, so we need to find f of pi over 6. So pi over 6 is going to be equal to, all right, so cosine of pi over 6 is what? Square root of 3 over 2. So 5 times square root of 3 over 2 squared minus 10 times sine of pi over 6 is 1/2. So it's a 1/2. Right, so this is going to be what's 5 times, and it's going to be 3 over 4, right, minus 5, so it's going to be 5. Right, so this is going to be, so it's going to be 15 over 4 minus 5 is same thing as 20 over 4. So it's going to be negative 5 over 4. Right, so if you look at the f of 5 pi over 6, then you're going to have 5 times. Right, so let's see, cosine of 5 pi over 6 is going to be negative square root of 3 over 2, but it gets squared, it's the same number, so minus 10. And sine of 5 over 2 is times the 1/2. It's actually exactly the same value, right? So it's going to be negative 5 over 4. Right, so we're going to have, so we're going to just type in negative 5 over 4, and here also negative 5 over 4. Right, so let's check the answer. All right, I came back and looks like we got inflection points correctly, and we want to find the interval which concave up and down. Let's see, let's go back. All right, so you can see that here, second derivative is negative, so we can see that this is going to be concave down between 0 and pi over 6. And between pi over 6 and 5 pi over 6, this is going to be concave upward. And after that, it's going to be concave downward. All right, so let's type it in. All right, so concave upward is going to be, I forgot, it's a between pi over 6. So we have a pi over 6 to 5 pi over 6. And then concave downward would be everywhere else. It's going to be between 0 and pi over 6. And then we're going to have a union. So I'll put a union there. And then we're going to have a 5 pi over 6 to 2 pi. All right, let's check the answer. All right, I came back and we got the interval of concave up and the concave downward. All right, that's it. I hope that this was clear.